Good morning. I'm Dr. Mahajabin Fatima from Electronics and Communication of Sagar Institute of Research and Technology. This institute comes under the banner of the SAGE Group. I'm taking lab experiments of control system via MATLAB. Subject code is EC404. Today I'm taking experiment number 7, step and impulse response of second order system. Aim is to draw the step and impulse response of the second order system. Objective is to learn how to plot step and impulse response of LTI system transfer function. The time response is the response or output of the system in the time domain. This time response is composed of transient response and steady state response. The transient response is the transition between initial state and steady state. The steady state is the manner in which the system output behaves as time approaches infinity. The first order systems and second order systems are stable with impulse and step inputs. Now I'm taking one example. Draw step and impulse response of second order system transfer function. So one transfer function is considered here, n equal to 16 upon s square plus 2s plus 16. So for this transfer function and for this second order system, the program is written and the program is written to plot step and impulse response. Here n equal to tf, this much value is written to calculate the transfer function. Here 16 is the coefficient of numerator polynomial and 1 space 2 space 16 are the coefficients of denominator polynomial. S square is having the coefficient of 1, so 1 is written here. S raised to 1 is having coefficient of 2, so 2 is written here. S raised to 0 is having coefficient of 16, so 16 is written here. So this transfer function is actually shows the second order system. Now I want to calculate and plot step and impulse response. For this purpose, I write here A equal to step within parenthesis n. So this command will calculate the step response of the system. It means the output will be calculated if step input is given for this transfer function or second order system. For the plotting of this step response, the plot command is given, then X label, Y label are done for labeling of x-axis and y-axis, then title is given, then b equal to impulse of n is written. This command will calculate the impulse response, that is the output of the second order system or of this system when impulse input is given. Then after this impulse response can be plotted with the help of plot command. Then X labeling, Y labeling will be doing to label the x-axis and y-axis, and title will be given. Now I'm doing this experiment on MATLAB. So I'm writing here n equal to transfer function within parentheses. I'm writing within square bracket the coefficients of numerator and denominator polynomials. I'm writing here. The denominator coefficients are 1, 2, and 16. See, this is 1, 2, and 16. So I'm writing here 1 space 2 space 16. Now this command will calculate the transfer function in S domain. So this is giving transfer function in S domain 16 upon S square plus 2S plus 16. This transfer function belongs to the second order system. So I'm writing here A equal to step within parentheses variable of transfer function. Here n is taken as the variable of the transfer function. Now place semicolon to hide the result. Now this command executed and it calculates the value of output when step input is given. Now I want to plot this step response. So I'm writing here plot within parenthesis A. Now you can see here the plot is available. Now you can see here the this is the step response for the second order system. It means this is the output when step input is given to the second order system. But I want to see the impulse and step response within a figure. So I am writing here subplot command. Subplot, I want to draw two plots, figure number 1, and here first plot I want to draw. So I'm writing here now plot A. So the subplot command helps in drawing number of plots in a figure. So here I want to draw two plots. So I wrote here 2. So with this command, you can see here. Now see, now this figure is available. Now on the number 1, the step response is drawn. Now x-axis and y-axis are not labeled. So I'm labeling here x-axis within parenthesis, sorry, x label within parenthesis, within apostrophe, I'm writing time. So this will write time on x-axis. Now I want to write y label within parenthesis, within apostrophe. I can write step response. Now this command will label the y-axis, and title I want to give. So title within parenthesis, within apostrophe, I'm writing here step response of second order system. Okay, so see this plot here. Now you can see here time is available on x-axis, step response is written on y-axis, and title is also available here. So x-axis is labeled and y-axis is also labeled. Title is also given here. Now come to the next plot, that is impulse response. Now you see here I wrote B equal to impulse of n. So this command will calculate the impulse response values. That is the output value when impulse input is given to the second order system. And then this impulse response will be plotted. So I'm executing commands here. I'm writing CLC here. Transfer function is already calculated, so I'm not writing it again. Now I'm writing B equal to impulse of n. Now this command executed and it calculates the impulse values for the second order system. Now I want to plot this impulse response within a figure. So I'm writing 2, 1, 2. This 2 is written. This 2 is written to plot the next plot on second position in the same figure. So I'm writing here plot of B. Now see the figure. Now you can see here in this figure the two plots are available. So with the help of the subplot command, the number of plots can be drawn in a single figure. So you can see here this is the step response of the second order system, and this is the impulse response of the second order system. You can see the difference between these two. In the first response, in the step response, the overshoot is not so high and the oscillations are also very less, and this output goes to the steady state soon. But here in the impulse response, the oscillations are more and the overshoot is also high as compared to step response. So now this impulse response, I want to label it. I want to label x-axis and y-axis. So x label, within parenthesis, within apostrophe, write time. Now label the y-axis. So y label, within parenthesis, within apostrophe, write impulse response. So this will label the y-axis. Now give the title to this plot. Title within parenthesis, within apostrophe. Now I'm writing here impulse response of second order system. Now see, this is the figure. Now this figure is complete. Time is available on x-axis, on y-axis impulse response is written, and title is also available here. So within a figure, two figures are drawn. This is the step response and this is impulse response. Now we can do the comparison of these two graphs. That is, if step input is given to the second order system, what will happen to the output, and if impulse input is given to the second order system, what will happen to the output. So with the help of this experiment, the comparison can be done. Now this completes this experiment. Thank you.